Now example, use binomial series to determine the expansion square root of 2x plus 2 over x, isn't it? So the first thing, what do you know? When you have square root, it simply implies it is 2x plus 2 over x raised to power a half. Power half is square root. Then you go to the binomial series, because this power is not a natural number. We are not going to use combinations because we know very well that when you have n combination 0, that is the same as n factorial over 0 factorial and n minus 0 factorials. Turning it into factorial notation, but it is still the binomial series. Are you seeing that? Yes. When you have a case like n combination 3, it is going to be n factorial over 3 factorial into n minus 3 factorial. Are you seeing that? So that n factorial you can expand into n minus 1 into n minus 2 into n minus 3 factorial over 3 factorial n minus 3 factorial. So that cancels with that. You remain with n into n minus 1 into n minus 2 over 3 factorial, isn't it? So it means the binomial series is either using this or this, but you only use this when the power is a natural number. But when the power is not a natural number like this, meaning this combinatorics must be represented in form of factorial notation. Are you seeing that? So that last example, we used the combination notation because n was a natural number, but now here, this is not a natural number, isn't it? So we can now not use the combinations, isn't it? We must use the factorial notation. Are you getting the point? Yes. Good. So we now want to use the factorial notation because the power n is not a natural number. So can we now use the factorial notation of the binomial series, okay? Good. So when you have, we said when you have a plus x raised to power n, then you know that n factorial is n into n minus 1 into n minus 2 into n minus 3. In that order, you just move until you reach 0 factorial, isn't it? Are we together? So you start. When you have 0 factorial, it means there's no term in the numerator, isn't it? Yes. Are we together? Then our x is raised to power that 0. Is that okay? Yes. Then a will be raised to power what? See, n minus 0. Is that okay? Yes. You move on. So maybe we want to expand this up to the term x squared. Are we together? We want to expand it up to the term x squared. The second one, plus, when you have 1 factorial, from 0 factorial we move to 1 factorial, isn't it? 1 factorial means there's 1 term in the numerator, isn't it? And that 1 term is n. So 1 term in the numerator is n. Then our x is raised to power this one, isn't it? Then it means a will be now the power n minus 1, isn't it? Are we together? Yes. You move on. After 1 factorial we move to 2. 2 factorial. 2 factorial means there are 2 terms in the numerator, isn't it? So what are those 2 terms? 1, 2, isn't it? Yes. N into n minus 1. Then our x is raised to power that 2, isn't it? Then it means a will now be n minus 2 because the sum of the 2 powers must add up to n, isn't it? Yes. Are we together? Yes. Is that okay? So we wanted to reach a term of x squared. So it means we reach there. Is that okay? We wanted to reach a term of x squared, so we don't need other terms. Is that understood? Good. So having done that, we now simplify it. You know that 0 factorial is 1, isn't it? X raised to power 0 is 1, isn't it? A raised to power n minus 1 is just an. Are we together? So if you simplify this, what do you get? A plus x raised to power n. This is 1 over 1, this is 1. Anything raised to power 0 is 1. N minus 0 is just an. So it means the first term there you remain with a 2 power n. Because 0 factorial is 1. 1 over 1 is 1, isn't it? N minus 0 is just n. So just remain with the n in the whole of this term. Then it is plus. Here we have n over 1 factorial. Then x raised to power 1 is just x, isn't it? Then we have a raised to power n minus 1, then plus n into n minus 1 over 2 factorial. Then x squared, a raised to power n minus 2. So bring your series and compare, isn't it? So you want to expand. Bring your expansion there. You have 2x plus 2 over x raised to power a half. Because we have x in this expansion, now what you do in this your formula, you now let it be x1 to be different from this, isn't it? You now let it to be x1 so that it is different from the expansion you want to deal with, isn't it? Are we together? So can we now start substituting A? What is A? The position where A is occupied we have is 2x, isn't it? Then you move, what is x1? The position x1 is occupied by 2 over x, because there's a positive sign in between both of them, isn't it? Then what is n? The position n is occupied by a half. So what we want to do is just substitution, isn't it? So do the substitution. Where there is a, you put 2x. Where there is x1, you put 2 over x, isn't it? And where there is n, you put a half. Is that okay? Yes. So what do we have? A raised to power n, that is 2x. Your n is, a is 2x, n is a half. We are substituting everything, isn't it? I move on, plus n is a half over 1 factorial, isn't it? Then x1 is, see x1 is 2 over x. Then an minus 1, what is a? A is 2x, isn't it? Then n minus 1, n is a half. Half minus 1, you get negative? Negative a half. Is that okay? Continue, plus, move here, n is a half, isn't it? Then into n minus half, n minus 1, a half minus 1 is negative. See, n minus 1 is a half minus 1. See, that is negative half, isn't it? Yes. Then it is over 2 factorial, isn't it? Then x1 squared. x1 is what? 2 over x. 2 over x. Then you are a raised to power n minus 2. A is 2x, isn't it? Yes. And it is raised to power n minus 2. N is a half. A half minus 2, you get negative 3 over n minus 2. N is a half. A half minus 2 is negative 3 over 2. Are we together there? Yes. So the next thing we do is to simplify, isn't it? Can we now simplify? Start. 2 raised to power half, x raised to power half, isn't it? Are we together? Yes. So go to the calculator. What is 2 raised to power half? One 1.41. 1.41. 1.41. Then x is raised to power half. Move to the next one. Plus. Here we have a half divided by 1 factorial, which is just a half, isn't it? Then it is times 2, isn't it? Are you saying we are simplifying this? Just go to the calculator and separate the nodes. This is a half divided by 1 factorial is a half. Then here you have 2 and 1 over x. 2 over x, it means 2 times 1 over x, isn't it? You are separating them. Then 2 raised to negative a half. And we also have x raised to negative. The power outside is for everything, isn't it? Meaning it is 2 raised to negative a half and x raised to negative half. So you separated everything, isn't it? So go to the calculator and deal with the numbers. 1 factorial is just 1. A half times 2 is 1. Then times 2 raised to power negative a half. What do you get? Then times 2 raised to negative a half. What do you get? 0.707. So that is 0.707. Then you can see this is 1 over x times x raised to power negative half. Remember 1 over x is the same as what? It's the same as x raised to negative 1, isn't it? So x raised to negative 1 times x raised to negative half, loss of indices, same base you add the powers, negative 1 plus negative a half. You get x raised to power negative 3 over 2, negative 1 plus negative a half. See, same base you add the powers. You get x raised to power negative 3 over 2. You are done with that term. So we've dealt with this first term, the second term, we are going to the last term. Are we together? I go to the calculator. A half times negative a half. We have a half times negative a half. Then you divide it by 2 factorial. Then here we have what? Look here. 2 squared. This square outside is for everything inside the bracket, isn't it? Are we together? So it is 2 squared, and here we have 1 over x squared, isn't it? So 1 over x squared is like that. See, this means it is, when you bring the square inside, it is 2 squared over x squared. So if you separate them, see here is 2 squared times 1 over x squared. You are separating the numbers from unknown, isn't it? Then you move on. 2x, all of it raised to negative 3 over 2, meaning 2 is raised to negative 3 over 2, and x is also raised to negative 3 over 2. They are sharing the same power, isn't it? Loss of indices, isn't it? Because this multiplication between, so 2 is raised to negative 3 over 2, x is raised to negative 3 over 2. So start from here. A half times negative a half, then divide by 2 factorial. Negative a quarter divided by 2 factorial. I can see the answer is negative 1 over 8. Why are you still wasting time with that? Negative 1 over 8. So negative 1 over 8 times 2 squared. You are moving in line. That is negative a half. Why are you wasting time? Negative a half. Then times 2 raised to power. 2 raised to power negative 3 over 2. Times 2 raised to power negative 3 over 2. Negative. So you multiplied all the numbers, isn't it? Yes. You found negative 0.176, isn't it? Then x is raised to power. Remember 1 over x squared. It means it is x raised to negative 2, isn't it? So x raised to negative 2 times x raised to negative 3 over 2. See, that is same base with multiplication sign, isn't it? Yes. Loss of indices, you add the powers, isn't it? Yes. So x raised to negative 2 times x raised to negative that, you get x raised to power negative 2 plus negative 3 over 2. Negative 2 plus negative 3 over 2. Negative 7 over 2. And you are done. You have simplified the whole of that problem. So have you seen we are moving stepwise to simplify a problem? We are moving stepwise to simplify a problem, and that is how to handle such a case.